going to be doing a video on some statics, going to do some resultant forces. This topic goes with my FE exam review. As you can see, statics, we have resultants of forces and equivalent force systems. But I'm just going to be covering A and B in these first few examples. So in this one, we have a block that's on an inclined plane which has 3 different forces acting on it. We're given that the angle A is 40 degrees and we need to find the resultant force. So the easiest way to do this is just to break up each force into their x and y components and add them up to see where they go to. But we have an inclined plane, so we can either do it, well, there's really 2 ways we can do this. We can stay with our traditional x and y. So we can either go like this, where we have our x-axis and our y-axis, or we can kind of modify it. So we have, I'm going to call this my x prime, and this is going to be my y prime axis. Either way works exactly the same, comes out with the same answer. You just have to do a little bit more or think about it a little bit more, but we're going to be doing both ways. So let's get started. I'm going to first do the traditional the traditional x and y axis. So I'm just going to have my x and my y, and I'm going to be breaking these up into its x and y components. So the first one, it's just 20 degrees off. So we just, for our x component, we do 60 cosine of 20. That gives us an x component of 56.38 pounds. And then for our y, it is 60 sine of 20. And since it is pointing up, it is going to be a positive y. Same thing with x, it is to the right, so both x and y are positive. Y is 20.52 pounds. So now we have our 80 pounds, and it is 40, because A is 40, plus 20, so it's 60 degrees off from our original XY axis. So we're going to have 80 cosine of 20, 60 degrees, and it is a positive 40. So it is positive 40 because it is only at 60 degrees. It is still in the first quadrant, so x is positive and y is positive. So we're going to have 80 sine of 60, and that is going to give us 40 times the square root of 3, which is 69.28 pounds. And so now we have our 120 pounds. So if we just want to start from our x-axis and work all the way around, we have 20 degrees plus 40. Well, actually, that's going to be 90. So we're going to have 20 plus 90 plus another 40. So that gives us 150. So that means if we're going to draw our original x-axis, that means this is going to be 30 degrees off, because, well, 180. So 180 minus 150 gives us 30 degrees. So we know our 120 pound force is acting or 30 degrees from the horizontal. The way that it's drawn, you can really say that it's in the 4th quadrant, but I'm gonna I'm just going to work on it the way it is here. So, excuse me, so we have 120 pounds times the cosine of 30. So that gives us 103.92 pounds. And it is positive because regardless if you put it in the fourth quadrant or just leave it like it is, you can see that the x component is still positive. So I'm gonna draw, kind of zoom in here, and I'm gonna draw another. So you can still see, even though I drew another coordinate system, it still acts in the fourth quadrant, but the x component is still positive. So, oh goodness. So coming to our y component, it is 120 times the sine of 30 degrees. 120 sine of 30. So that gives us a negative 60 pounds for our y component. So if we add all these up, we have 56.38 plus 40 plus 103.92. It gives us an x resultant of 200.3 pounds. And so our y is going to be 20.52 plus 69.28 minus 60. Calculator went haywire. Plus 69.28 minus 60 gives us a y component of 29.8 pounds. So our total resultant is going to be x squared plus y squared. So we have 200.3 squared plus 29.8 squared, and taking the square root of that, we get our overall resultant, where the magnitude is equal to 202.5 pounds. 202.5 pounds. And so we need to find out which direction this resultant is in, which we can easily do that by, because we know that tan theta is equal to our force in the y over force in the x. So we have theta is equal to the tan inverse of 29.8 over 200.3. 29.8 divided by 200.3. So that gives us is equal to 8.46 degrees from the horizontal. So our theta is 8.46 degrees, and our overall resultant is 202 pounds, or you can just round up to 203. So now I want to take another approach. I'm going to delete my original x and y, and now I'm going to come over here and make it like that. So I have y prime. Let me just do this in a different color. So this is going to be x prime, and this is going to be y prime. So again, just making my own little box here. So my first x component is just 60 since it lies on the x prime axis. So my first component is 60 with the 0 for the y. And so now I have my 80 pound, it's still in the first quadrant, so it's going to be 80 times the cosine of 40 degrees, which is going to be 61.28. So 61.28. And my y is going to be 80 sine of 40, which is going to be 51.42 pounds. So now 120 pounds. He is in the, or I'm going to say he's in the second quadrant, but you can move him and place him in the fourth if that's how you like. But since A is 40, that means this angle right here is now 50 degrees, because that has to make up 90. So we're going to have, I guess I could just work with 40, but I like the way I'm just going to keep the way I'm going. So I have 120 times the cosine of 50 degrees. Cosine, so that is going to be a positive x. So he's going to have a positive x of 77.13 pounds. However, his y component is going to be down, so it's going to be 120 times the sine of 50 degrees, which is going to be negative 91.93 pounds. Again, his x is positive because, let's erase this. I guess you could make a little triangle out of it and see that his x is positive and his y is negative. So oh goodness. Alrighty. So now we can do the same thing and add all this stuff up. So we have 60 plus 61.28 plus 77.13, which gives us 198.41 pounds. And adding up our y, we get a total of negative 40.51. So we can do the same thing, is equal to our force in the y squared plus force in the x squared. So that gives us 198.41 squared plus 40.51 squared. Taking the square root, we get the same thing as 202.5 pounds. Now our theta is equal to the tan inverse of negative 40.51 over 198.41. So our theta, negative 40.51 divided by 198.41, is going to be negative 11.54 degrees. So what does that mean? That means if we come here, our theta is going to be negative 11.53 degrees with respect to our modified x-axis. So this is negative 0.53 degrees. It didn't pass 20, so it still has to be in the first quadrant. If this would have been negative 20 instead of negative 11, we would have known that it would have lied perfectly on our original y axis or our x-axis. But since it's negative 11.52, we need to add that to our 20, and so that gives us an overall theta So we're going to have theta is equal to negative 11.54 plus our 20 degrees, which gives us 8.46 degrees. So either way you want to look at it, it'll give you the same answer. Just the second one might be a little bit confusing since you got to remember to add your 20 degrees, but it's nothing too bad, just some basic resultant forces. So the next one I want to look at is we have I guess a tower with 3 wires holding on to it, and the cable AB is 65 feet long with a tension of 3,900 pounds. We need to determine the X, Y, and Z components of the force acting on anchor B. We also want to find our direction cosines. So AB is 65 feet long. So 65 feet. And it is also 3,900 pounds in tension. I guess I need to put my units. I don't like units because the stylus is pretty bad, not really accurate, so don't want to make it look like it's 39,001 or whatnot, but 3,900 pounds. And so what we can do is we know this force is 3,900 pounds in AB. Oh, wrong color. Or I guess AB is 3,900 pounds. But we can find our X, Y, and Z because it is just a projection of that force onto the Y, onto the X, and onto the Z. So we can easily find out what our Fy is. Our Fy is going to be 3,900 pounds times the sine of that angle. So whatever that angle is. So we can do tan inverse of 56 over 65, or you can just write it into its components of, or you could just do sine and then just put it into its components of 56 over 65. Either way, works the same. So we get 3,900 times 56 divided by 65. So our projection onto the y-axis is going to be 3,360 pounds. And so now we need to find out what this length is from O to B. Well, I guess we could do 65 squared minus 56 squared. Take the square root of that, and we get a length OB is equal to 33 feet. So now we can find out what this force in OB is. So again, using our 3,900 pounds, we could do 3,900. Let me make this a little bit. 3,900, and it's 33 over 65. So 3,900 times 33 over 65 gives us a grand total of 1,980 pounds. So that is what force OB is. However, force OB doesn't tell us anything because it is both the X and the Y. So now we need to break this up a little bit further, and we need to find out what the Z is and what the x is. So make that a different color. So now I guess I'm going to find out what the x component is. We're not given any lengths, we're just given an angle, so now we can work with our sines and cosines. So my fx, fx equals our force OB, which we found to be 1,980 pounds, times, don't know why I put parentheses, times the cosine of 20 degrees. So 1980 cosine of 20 gives us 1860.59 pounds. And our Fz is going to be a negative value. Now, how am I getting positives? Because I know from B, the force that is going, the tension AB, the tension, of 3,900 pounds is directed up. So, that would make my x negative. Okay, yeah. So our force AB is being directed up, and Z, it is that way, and our x component is directed that way. So that means my fx component is negative. So we have a negative 1860. And so our Fz is going to be positive because it is in the positive z direction. And so we're going to have, again, what color did I use? Blue. So we're going to have Fz is equal to 1980 times the sine of 20 degrees. So 1980 times the sine of 20 gives us a negative, or positive, 677.2 pounds. So that is what our Fy, or our Fx, Fy, and Fz are. So now we want to find out what the overall resultant is. It's just, so our overall resultant is equal to the square root of fx squared plus Fy squared plus Fz squared. Or I guess I could just call this the big F. So we're going to have 677.2 squared plus 1860.59 squared plus our Fy, which was 3360 squared. Take the square root of that. So we know that this all adds up to our original tension, because the original tension was 3,900 pounds. So we just kind of verified that everything kind of added up. So now to find our direction cosines, our cosine theta x is equal to our fx over f. And same thing with cosine theta y is equal to Fy over F, and cosine theta z is equal to our FZF. So going back up here, our Fy was 3360, so we're going to do cosine inverse 3360 divided by 3900. So our theta x is equal to 30.51 degrees. Theta y is equal to the cosine inverse of Fy. Oh no, that was Fy. Oh. So that is Fy. Fx is going to be cosine inverse of negative 1860.59 divided by 3900. And so we get 118.5 degrees. And theta z is equal to cosine inverse of 677.2 divided by 3900. Oh, we don't want no ads. Is 80 degrees. And that is how we do this. Oh, get rid of that ad there real quick. And this is our overall direction cosines and our forces acting on the anchor at B. And what do these direction cosines tell us? They tell us that, I guess, I'm going to attempt to draw something. So they tell us, I'm just gonna draw an arbitrary thing here. So that tells us theta y is what? Was 30.51. So from the y to our cable, it is 31 point. I'm just going to label this theta y. And so now theta x is kind of the same idea. From the x-axis to that point, that wow, a lot of arrows. And our theta z is the same thing. It's from our z-axis to that point, to that cable. So that is what our directions cosines are telling us. And so there they are, and our forces Fx, Fy, and Fz. If you have any questions, don't hesitate to ask me. I'll do my best to clarify, and we'll see you in the next video.